Okay, class, this is section 7.2. We're going to be doing some applications of the normal distribution that we just learned in the last section. So the standardizing of a normal, this is the formula. And so what we can do with this is we can change any type of data that we have, whether it's the weight of giraffes, or if it's the height of a person, or anything, IQ scores. We can change all of those, all of that data into z-scores. And the good thing about z-scores is you get to use that one table, that one common table for all the different distributions. And so that's what this does. And so any type of data we get, we can change into z-scores. So let's move down. And so we sort of talked about z-scores earlier, just barely. But this is the standard normal curve. The 0 in the middle is the mean of, because when you turn everything into a z-score, the middle is the mean, which is 0 in z world. One standard deviation out is just 1, and then -1 on the other side, and so on and so on. Okay, so the table that we are going to be using gives you to the right, to the left of your boundary line. So if this is the statistic that you're looking at and you change it into a z-score, the table will give you this probability. So it's going to be always to the left. So let's do this first problem down here and see how it all works. Okay, so it says IQ scores can be modeled by a normal distribution. That means we get to use our normal curve in our z-scores. It's got a standard deviation of 100, a mean of 100, and a standard deviation of 15. So let's draw our picture with our raw data. So this is our raw data. This is going to be at 100. Let's go ahead and stick a couple of standard deviations on there. So this one's going to be at 115. If you put one back here, it's going to be at 85. You can put some more because 100 minus 15 is 85. So you can put some more on there if you want to. Okay, so now it says an individual whose IQ score is 120. So that means they're falling way over here. So this is our 120 mark. Okay, is 1.33. And so how they get that, sorry about that. So how they get that is they just use their z-score. So this is, or their z-conversion formula. So this is always the thing that you're testing minus the mu divided by standard deviation. And so that's how they're getting this 1.33. I'll just go ahead and do it. So we're testing 120. Our mu is 100. And our standard deviation is 15. And if you crank all that out, you're going to get 1.33. Okay, so that's how they get the 1.33. And so what the z-table gives us is it gives us the probability, or the area, because those are the same, the area of all of this space to the left of that 120. Okay, so if this is our raw data, and let's put our z data under here also. That's going to be 0 is the middle, 1 standard deviation is 1 for z world, and then the thing that we're testing is 1.33. And so that's how they get, and this one would be -1 over here. And so that's how they change the raw data into a z-score. Okay, and so how do you read your table? Is you just go onto the side. It is the first decimal place, and then along the top is the second decimal place. So go to 1.3, and then you're going to go over to 3. So it's 1.33. And so there is the area to the left of that boundary. So it's going to be 0.90 1.082. And so what that really means is if you scored 120 on an IQ test, you are basically in the top 91 percentile. This rounds to 91. Okay, so that means you have a IQ score higher than about 91% of the population. So awesome. Okay, so let's move down. Okay, we're going to do the exact same problem, except for we're going to find the area to the right of our boundary. So you can write the raw data again and the z data again, but this is, I'm just going to sort of write that boundary. Basically what they're wanting is they're wanting the other side. Well, how do we find the other side? Well, here's how you find the other side. Remember our complement rule? Well, also remember the whole entire area underneath this whole entire curve has to be 1. So if we know part of it, then we should be able to find the other part by subtracting 1, or 1 minus that. Okay, so we just found this area over here. What did we find it as? 0.9082 on the last problem. And so if that's 0.9082, what's the other part of it? Well, all we have to do is subtract. So here's how you would really write it if you were going to write it technically. Probability that your z is bigger than or equal to 1.33 is just 1 minus the probability that z is less than 1.33. And we already did the probability of z is less than 1.33. It's 0.9082. And so all you have to do is 1 minus it. So it's basically just the flip side. And so 0.0918 is what we get. So basically that means if you score 120 on your IQ, there's only about 9% of the population that's higher than you. So that's pretty awesome. Okay, so let's move to the next one. So we're going to do this one. We're going to do, and you're just going to be practicing with the normal curve. Okay, so it says find the area under the standard. And remember, area is the same thing as the probability. Those are exactly the same thing because that's what we've been finding, is the area of whatever data we're looking at. Okay, so find the area under the standard normal curve to the left of negative 0.38. Well, there is something that I know, and I always like to draw my pictures. So they didn't give us any raw data, that just gave us the z data, so I'm just going to write the z data. So there's always 0, 1 standard deviation out is always 1, and negative 1 on this side. So first of all, where is this line going to show up? I already know it's on the negative side, but it's not quite to 1. So it's going to show up right about here. So I always draw a picture just because I'm super visual and I got to see what's happening. So basically that's what it's asking us. It's asking us for what is that probability. So the probability that z is less than negative 0.38, just go to your chart, and that's what your chart gives you, is to the left, so we don't have to do any fancy things. So there's a negative 0.3, and then go over to 8, and so there it is, 0.3520. And so that's it. All right, moving on down to the next one. Okay, so find the area under the standard normal curve to the right. Okay, so that means I'm going to have to do that little complement rule thing. But here is, oops, I made that line a little bit long. Here is our basic z data, our z boundaries that I like to put on the graph. Okay, if we're looking for 1.25, that means it's going to be past this first standard deviation, past this z is equal to 1. So it's going to be like right about here. And so this is what we're looking for. So 1.25. Okay, well, how do we do that? Is we're going to have to do the flip side, because remember, when we find 1.25, whoops, when we find 1.25, it gives us to the left, the probability, the area to the left, not the right. So the way that we have to do that is we're just going to do the probability that z is bigger than 1.25 is just 1 minus the probability that it's smaller. Come on, smaller than 1.25, which is just going to be 1 minus. You're going to have to go to your graph, to your Z chart and look it up. I don't have it on this one. I just did a little portion of it. So you got to go look at your real Z chart, go to 1.2 on the side, and go over to 5. 1.25. I got 0.8944. And so the flip side of that is just when you subtract 1 minus 0.8944, and I always call that the flip side just because this is part of the graph and the flip side is the other part of the graph, and it takes up the whole graph. So 1056 is what I get. Okay, so we see how all of that works. Let's go down to the next one. How am I going to find something between two pieces? So let's draw our data. There's 0. Here's a 1, negative 1. Here's a positive 1. Those are the ones I always draw. Okay, this z is going to be just below that negative 1, so it's going to be right at, well, it's not. It's probably closer than that, but I can't draw this very well. Uh-oh. Our smoke alarm's going off. My daughter's cooking. It's all bad. Okay. Sorry I put y'all on pause. I was just making sure there's no fire. There's no fire. Okay, so this first boundary is negative 1.02. And then we also have another boundary way over here, so it's even past the second standard deviation, which I usually don't write, but it's going to be like super far over here, 2.94. Well, how the heck am I going to get that? So I just want this part from that one dotted line to this one dotted line over here. Because if I find the boundary of this guy on the Z chart, it's going to give me everything all the way down. So it's going to give me from here all the way to the end. But I don't want all the way to the end. I want to cut this off. So how do we do that? Well, we have to find this one, but then we got to cut this piece off. So basically what we have to do is we have to find the probability, the area to the left of this boundary, to the left of 2.94, and subtract off this boundary because that's what I don't want. So if I take this whole thing all the way down, it's going to give me all the way, and I don't want this part, so I got to chop this part off. So I'm going to do minusing the probability that z is less than negative 1.02. Okay, so you just look both of those up. You're going to go to 2, which is pretty far down on your chart, 2.94. I got it. 0.9984. That's what I got for this one. And then also on your chart, you can go to negative, so that's going to be at the top of your graph. Negative 1.02. I got 0.1539. 0.1539. And so that is 0.8445. So you got about an 84.4 or 84.5% chance of falling in between these two boundaries. Okay, so here's the summary. First thing you're going to do is you're going to draw your normal curve, shade whatever area they're asking you for. You're going to convert your your raw data into ZData, and then find those boundary lines, and then you're going to use the Z table to find your desired area. Okay, and here's the way that you can find each one of these. We just did each one of these. Okay, to find the area to the left, you just find the z-score because that gives you the left. Find the area to the right, you find the z-score, and then you have to do the flip side thing, 1 minus. Okay, and to find the area in between, you just have to take the highest one and then cut off the lowest one. Okay, so here is our first problem. It says men have a normally distributed, so that means I get to use my z-chart. Normally distributed heights, here is their mean, and here's their standard deviation. So let's draw. I like to do the raw data and the z data. So here's the middle. This is going to be my raw, and then I'm going to do z down here. Okay, so my raw data is 69.5. I'm going to go ahead and put a couple of my first standard deviations out there, and so each standard deviation away is just going to be 69.5 plus and minus 2.4, plus 2.4 for one side, so that gave me 71.9, and then this side is 69.5 minus 2.4, which is 67.1. Okay, all right, so, and then if we did those into z-scores, this would be 0, this would be a positive 1, this would be a negative 1. Okay, and so what is it asking us? If a man is chosen at random, find the probability that his height is below 72 inches. So here is about, it's going to be real close to that first standard deviation. Okay, and so there is 72. I'll write it real small. So what that means is I got to find this z-score down here that correlates with the 72. So the first thing I'm going to do is find that z-score. And then once I find the z-score, I can use my chart to find the probability. Okay, so x minus mu over standard deviation. So remember, this x is always what we're testing. So what we're testing is the 72 minus the mean, which is 69.5, divided by 2.4. Okay, when you crank that all out, you're going to get 1.04, because remember on the z table, we just need 2 decimal places because that's all it goes. So we're going to look up 1.04. So the probability that a person's height is less than 6 feet or 72 inches is exactly the same thing as saying the probability of z less than 1.04. And so, since we don't have a table with 72 on it, but we do have a table with 1.04 on it, we get to look at the z at the normal chart. And so what is that going to be? Go down on the side, 1.0, and then over to 4. So 0.8508. So 0.8508. So if you pick somebody, there's a probability, there's an 85% probability chance, there's an 85% chance that they're going to be below 6 feet. So basically what we found was all the stuff all the way to that dotted line. So all this area right here. Okay. All right, let's move to the next one. Lengths of human pregnancies are normally distributed with a mean of 268 days and standard deviation of 15 days. So here's our raw data. Here's 268. 1 standard deviation and 1 standard deviation out. 268 plus 15. Uh-oh. 268 plus 15 is 283. 268 minus 15 is 253. All right, so if we change all this into z, this is going to be 0, 1, -1. Okay, so now it says, what is the probability that a pregnancy lasts more than 240 days? So, where's 240 on our thing? Well, it's super far way down here. So, what's the chance of you having a pregnancy that lasts more than 240 days? A lot, because there's a lot of the chart that's under. So it's just all this from that little dotted line on. So it's going to be most people. So the first thing we need to do is we need to find the z-score that matches that 240. So z equals x minus mu over standard deviation. So that's going to be 240 minus 268 divided by 15. And when you crank all of that out, it is going to be negative, hold on, 240 minus 268. I got negative 28 on the top divided by 15. So I got negative 1.87 when you round it. 1.87, which I already knew was going to be below that first standard deviation, because 240 is below that first standard deviation, and this is telling me that it's below. It's actually in between the first standard deviation on the left and the second one. So now I have to do, what's the probability that a pregnancy lasts more than 240 days? Well, that's exactly the same thing as saying, what's the probability that z is bigger than negative 1.87? Well, remember, this is giving us to the right of that boundary, so we're going to have to do that one minus thing. We're going to do the flip side, because the chart gives us the boundary in to the left. What we want is the boundary into the right, so we have to do 1 minus. And so look up negative 1.87, and that is going to give us 0.0307. And so when you do 1 minus that, it's going to be 0.9693. And so what that means is, if you pick a pregnancy, 97% of the time it's going to be, that pregnancy is going to last more than 240 days. And so that's how you do it. All right, number 3 says this loan officer needs to rate applicants for credit, and so the ratings are normally distributed, so that means we get to use our normal curve. A mean is 200, standard deviation is 50. So let's just, instead of getting overloaded with all of our information, let's go ahead and write some of that down. Okay, so this is going to be my raw data, and I always like to put the z data underneath. So this is 200. First standard deviation is 50, so this is going to be at 250. And then this standard deviation this way is going to be at 150. Okay, so now there's my raw data. Now I'm going to do my z data. That's 0, that's 1, that's -1. Okay, so it says if an applicant is randomly selected, find the probability of a rating between these two. Well, remember how we do between? Because on the z chart, it only gives us to the left, readings to the left. And so this would be about 220. I'll try to write it really small, but oh, that's not working. there's my 220. Okay, and then my other one is going to be right over here at 170. And so they're going to be within the first standard deviations. So I already know something about my z-scores. My z-scores are going to be less than 1 and then greater than -1 over. They're going to be in between -1 and +1 because our boundaries are. So do we remember how to get the middle of something? Because remember, the z-score chart gives us all the way from that boundary to the left. So if we want just the inside of these dotted lines, then we're going to have to do, well, if we take the probability below this boundary, it's going to give us everything. So that means we need to get rid of this part of it. So what we're going to do is we're going to find the probability below the top boundary, and then we're going to chop off the probability below the lower boundary, and that will leave us with the middle stuff. So what that means is I need to find z-scores, both of these z-scores down here, and then the one that's over here also. So doesn't matter which one you do first. Let's just go ahead and do the 170 just because it's, I don't know why. Okay, so here's my formula. It's whatever we're testing minus the mu divided by the standard deviation. So that's going to be 170 is what we're testing, minus 200, that's the mu, divided by 50. And when you crank all that out, you're going to get -0.6, which is exactly what we thought it was going to be, because that's about where it's falling on our z part of the picture. Okay, and so then let's do the same thing for the 220. Okay, so formula, I'm a creature of habit. I always write the formula, even though it's right there. Okay, so I'm going to stick in 220 because that's what I'm testing, minusing 200 divided by 50. And when you crank all that out, it's going to give you 0.4. So what we're looking for, let me just draw a little line here. Okay, so what we're looking for is, what's the probability that the rating, if we pick one random person, that the rating is going to be in between these. And this is the way you're going to see it a lot, so I'll write it that way. And what this means is, what's the probability that the score we pick is going to be in between these two guys? So how do we do that? Is we have to do the probability of, well, actually, let me erase that and just start writing it in z-scores already. So that's the same thing as the probability that z is between -0.6 and not negative, just regular 0.4. Okay, so how do we do that in between thing? Is we have to take the bigger one, probability that z is less than 0.4, and then we have to minus off the part below the lower one. So it's going to be the probability that z is less than -0.6. Kind of got squishy, sorry about that. Okay, so we just have to go to our z table and find those two. So if z is less than 0.4, that's 0.40. So go on the side to 0.4 and then the first column, because that would be 0.40. So I just got 0.6554. Okay, so that's going to be 0.6554. Do the same thing for this one, except for it's negative. So go to -0.6, and then it's that very first column. So it's going to be 0.2743. 0.2743. And then when you subtract those guys, you're going to get 0.3811. So what that means is if you pick a random person, the probability that their credit score is going to be between 170 and 220 is about 38%. Okay, so that's how this all works. All right, so now that we know how to do that forward, we're going to actually go backward. Okay,